Hello to you. My name is Jesse Johnson. This is the shortened version of Permanent Magnets Working Semi-Perpetual Machine, the Johnson Self-Climbing Machine, or JSCM. This is to produce 250 billion watts per day or more. Invention is freely given to the whole world. Please translate this video into every language for every country. Share and spread worldwide. There are two types of machines, initiator and non-initiator. Initiator machine runs energy produced back into the initiator to keep the machine going. No external energy needed. Drawings for this machine is a semi-perpetual machine mainly to produce electricity. Semi-perpetual machines are possible and can be built with long-lasting output over weeks, months, or years. This particular perpetual machine is basic physics, basic machinery, and basic mechanics. System uses three fields: electric, permanent magnet, earth force field, EFF. Let's begin, please. Once again, this is how to construct and make a working semi-perpetual machine. This is the Johnson Self-Climbing Machine, or JSCM, and this is to produce electricity, roughly 125 billion or more watts per day and over. This is a power plant to turn electric generators. It is an alternative energy system. Now, this is illustration A, a hydroelectricity production, which is the principle this machine is based on. Water on a table at position A falls down in direction B and accumulates at position C. While falling, the water turns turbine fan blades of a turbine. The turbine is connected to an electric generator, producing electricity which goes through the system to your house. The physics principle here is that the force to make the water fall from A to C is equal to the amount of force it takes to have the water go back from C all the way back to A. The problem to solve is to do this with a solid system instead of with liquid water. The machine in that particular case falls, climbs, etc. repeatedly, indefinitely. Now, this is illustration B. This is how much electrical power in watts, 555 tons, falling per second, per day, per year, can be produced. The greater the dead weights of the machine, the greater the watts produced. Electric power in watts. Horsepower, HP is horsepower, D equals day, W equals watts, G equals billions. Number one horsepower equals 550 pounds per feet per second. It also equals 746 watts a second. Number two, 1 horsepower per day equals 64,454,400 watts a day. 4 horsepower equals 257,817,600 watts a day. 4 times 100 is 400 watts. 400 horsepower. 400 horsepower equals 25,718,760,000 watts a day. Number 5 here. Multiply that by 5, which is 2,000 horsepower, which would equal 125,908,800,000 watts a day, about 126 billion watts a day, gigawatts. Number 6, 126 gigawatts a day equals 555 tons gross falling per second times 86,400 seconds. That's a day. Let's continue, please. We'll start with number 1 up here. 1 horsepower equals 555 pounds falling per second times 86,400. That's a day. And in times 365 days, it equals 23,525,856,000 watts a year. We'll go to number 2 right here. 555 tons falling per second per day times 365 days equals 46 trillion watts per year. We'll go to number 3 here. 1,025 tons falling per second per day, each second per day, equals 251,817,600,000 watts. Pardon me, 251,817,600,000 watts per day times 365 equals 92 trillion watts a year. This here is illustration C. The machine is made of three main parts: two or more dead weights, a frame, dead weights, a frame for the dead weights to climb up on, a frame, and a slide magnet cage to make the whole system operable. This is illustration D. This is a side view. A major physics principle of this machine is permanent magnetic field balancing. This is done by putting a piece of common highly magnetizable metal right here in the middle right here, highly magnetizable metal of an exact thickness, exact length, and exact width, precisely in the middle of two magnets of exacting dimensions that are repelling each other, either south-south or north-north, but are attracted to the metal, with equal but opposing force. The fields balance and the directions of the magnets are cancelled. Magnets A and B repel each other, but they are attracted to the metal. The repulsion of the magnets to each other is equal to the attraction of the magnets to the metal. This balances the field. Now, these are the parts of the machine from 1 through 33. From 1 through in sequential order: cage racket, initiator, field balance metal, slide magnet cage, magnet 5, frame, pulley, wheels, handle brace, handle lift, handle, counterweight, ratchet 21 pin, counterweight table, counterweight rail, frame rack gears, floor pad, rack gear, ratchet, magnet spring, cage halter, magnet, field balance metal 27 cord, dead weight, magnet 5 jacket, 10 to 11 cord, time pins, rise and fall start pins, initiator battery in positions A through H. This here is the machine. As you can see, this is illustration F. This is the front. This is a front view of the machine and how it operates when climbing, so that it may fall again repeatedly and indefinitely. Operational. We'll start with number 1. The counterweight 12 is at position 8. Number 12 is at position 8. Pressing down ratchet 21, number 13. Pressing down ratchet 21 pin, number 13. This is number 13 right here. This is the ratchet 21 pin, number 13. And the handle 11 is right here in this yellow right here. Handle 11 is at position E. It's down here at E when it begins. And the bottom of the dead weight, 28, the dead weight is this total yellow block. This total yellow block is at position F. Its bottom is at position F right here, its bottom, which is on top of 18, which is on top of the pad right here, number 18. Now the magnet 22 is at position D. Magnet 22, this is magnet 22, is at position D. And the bottom of the slide magnet cage, number 4, the slide magnet cage, this yellow rectangle all the way around here, is at position G. Magnet number 5 is at position A. This is magnet number 5 is at position A right here. And the ratchet 21 is pushed back into the dead weight 28 at position C. This is ratchet 21 being pushed back here at position C right here. Right here. This begins the process of climbing. We'll go to number 2 now. The magnet 22 attracts to the underside of the field balancing metal number 3. Number 22 attracts to this field balancing metal number 3. Number 3 is right here. Number 3, it's in blue. And this picks up the whole dead weight. Number 28, the whole dead weight, which is 28, which is attached to the magnet 22. They're attached. 22 and 28 is attached. And the handle lift number 10, that's right here, handle lift number 10, which is attached to the dead weight right here, number 10 right here. Number 10 is attached to the dead weight 28, is also attached by 10 to 11 cord 30. Number 30 is right here, and number 30 goes right here. There's a little small piece of cord right here, attached to number 10, and is also attached to number 11, the handle right here, attached to 11. Now, this is cord number 30 right there now, which itself is attached to the handle 11, of course. All of them go up simultaneously. As the dead weight 28 goes up, handle lift number 10 goes up and pulls handle 11 up. Number 10, this one here, number 10, right here, hook here, number 10 goes up and it pulls number 11 up by number 30. And let's see now, which picks up the counterweight 12, which the handle is hooked to the counterweight here, which picks up the counterweight number 12 here, and by its cord 27 segment. Right here is a segment from right here to 11 to 12 is a segment of number 27, a 27 segment of the cord. Now, which is tied to handle lift number 10 and handle number 11. When counterweight number 12 is high enough, it lets ratchet 21 pin number 13 right here, there's a pin right here, number 13, now become completely extended, of which ratchet 21 pins 13 is coupled to the counterweight table. This is the counterweight table right here attached to 28. Counterweight table number 14 right here is attached to this by some mechanism through the table and all the way up to 21, which allows it to pull number 21 back. Now, coupled to 21, table 14, of which is attached to the dead weight, and the ratchet 21 number 13 pin by mechanisms is coupled to the ratchet 21. This is to pull 21 backwards from being meshed with frame rack gear, 16's teeth. This is 16. The teeth of number 6 is a rack gear right here, number 16. And it goes all the length of the frame, all the way the length of the frame, number 16. Frame rack gears, and to start upward climb of the total system. Number 3 now. The counterweight number 12 moves stably up and down counterweight rail number 15. Number 15 is right here, and this is the rail, so this to stabilize 12, and for linear control when things are in operation. Now, as dead weight 28 goes up, this compresses the springs 23. These are the springs. It compresses these. When it goes up, it compresses them. Now the dead weight 28 cannot fall. It can't fall down because of ratchet 20. Ratchet 20 is right here. It cannot fall down. It cannot fall back down as it goes up. The handle number 11 is held in place stably by handle brace. Handle brace number 9 is right here, and it holds the handle in place, which the number 9 is attached to number 7, which is attached to number 4 right here. Number 4 is the slide magnet cage, and which in turn is held stably by pulling number 7 system, which itself is attached to the slide magnet cage number 4. The weight of the dead weight 28 pulls slide magnet cage number 4 downward when going up, and slide magnet cage number 4 cannot fall because of its own cage ratchet number 1. That's right here, cage ratchet number 1, right there. It cannot fall. And this ratchet can also hold up the dead weight 28's weight. Now we'll go to number 4. While the dead weight 28, right here, goes up, it is able to climb frame number 6. Frame number 6. Frame number 6 is this. It's the whole frame. The whole frame. It's able to climb this frame. Climb it. Climb the frame. Now, as magnet 20 goes up, its surface, now number 4, while dead weight 28 goes up, it's able to climb frame number 6 several inches at a time, using the frame rack gear teeth, number 16 of course, and as magnet 22 goes up, its surface stops 1/100th of an inch from the surface of the field balancing metal number 3. It goes up and stops 1/100th of an inch from touching the blue, from touching the field balancing metal here, number 3. and they do not make contact or touch. Now, between 22 and 25 is field balancing metal number 26. That's number 26, field balancing metal, right here between 5 and 25. And, pardon me, between 22 and 25, between 22 and 25, 22 and 25. And between 5 and 22 is field balancing metal number 3, right here. Now, this is to bring the magnets to zero in force, and they do not contact or touch. And the 22 and between magnet 22 and 25 is a field balanced metal 26, and between magnet number 5 and magnet 25, pardon me, number 5 and 25 is field balanced metal number 3. This balances the fields of these magnets to zero when in operation. Now, when the magnet 22 comes to a stop, initiator number 2 comes on. This is initiator number 2. It comes on instantly and comes on and pulls magnets 5 from position A all the way to position B, over and above magnet 22. And therefore their force is zeroed out above and over magnet 22, with field balancing metal exactly in the middle between them. Magnet 5 surface also stops 1/100th of an inch from the surface of field balancing metal number 3. This balances the magnet's fields to zero. And if the neodymium magnets weigh 100 pounds each, then the initiator only needs about 3 or 4 pounds of pulling force to pull it this way. Only needs 3 or 4 pounds if these magnets were 100 pounds each. Now, let's go to number 5. In order to break number 22 magnetic field strength hold on the field balancing metal, number 3, field balance is needed, otherwise the system won't work. Magnet 22's magnetic hold on field balanced metal number 3 is reduced to zero, and it can now be moved away from it. Once magnet 5 is at position B, spring number 23 is unlatched, and it decompresses and pushes slide magnet cage 4 upward. It decompresses and pushes upward. Now the slide magnet cage number 4 goes up and is halted by cage halter number 24. This is a cage halter number 24 right here, and by 24. Now this separates the magnet 22 and the slide magnet cage number 4 once again. And once the slide magnet cage number 4 reaches position G, once its bottom reaches position G again, as it started in the beginning, as it was in the beginning, above dead weight 28, and magnet 22 is again at position D. Once it's separated with all of this space between it again, D, ratchet 21 is instantly released to mesh with teeth of frame. Ratchet 21 is released, and it goes back into the teeth of number 16, which is the frame rack gear teeth. It meshes back again. This is mess with the frame rate, and the magnet 22 again is at position D. Ratchet 21 instantly is released to mesh with teeth of frame rack gear 16 by its timing pins along the frame. There are timing pins all along this frame, all along, to make certain everything is timed correctly. Along the frame number 6. This keeps dead weight 28 from going up until the right time when you have 21 in place. It keeps the frame from going up from this magnet from sticking to this at the right time, for the right time only. Now, initiator number 2 is shut off. And counterweight number 12 is released and falls and pulls magnet 5, which was at B, it pulls it back to A again. Falls, it compresses 13, which pulls ratchet 21 back into the 28 dead weight at position C again, as in the beginning. And it does this by pulling magnet 5 horizontally over the field balanced metal number 3 surface by using wheels. These are small wheels right here. If you look at the blue, there are little wheels. This is to reduce friction when this magnet goes back to A by using the wheels to position A again, by using cord number 27. Now we'll go to 6. Counterweight number 12 falls and compresses ratchet 21 pin number 13. This pulls the ratchet 21 inward from the frame rack gear 16 to position C again. And the simple process is repeated until the dead weight climbs and reaches top of frame 6. When slide magnet cage 4 and dead weight 28 reach to the top of the frame itself, when it reaches to the top of the frame of 6, simultaneously both slide magnet cage and dead weight 28 contact their timing pins up here 21 and 31 timing pins 31 timing pins that timing pins 31, which is attached to the frame. There are timing pins all along the frame, Now this which unmeshes the cage slide ratchet number 1 ratchet. Also ratchet number 20 is unmeshed. Number 21 is unmeshed from the frame rack gears number 16. And over here 16 unmeshed. And the total slide magnet cage 4 and the dead weight 28 falls freely downward towards the bottom of the frame 6 to the pad 18, which cushions it. Number 18 falls downward to the pad 18 down here in blue, and which cushions it. This takes 1 second, regardless of how much pounds or tons dead weight 28 weighs. The amount of time in seconds that the dead weight 28 takes to get to the top of the frame number 6 from the bottom is the amount of dead weights in the system. 1 dead weight per second falls. When dead weight 28 gets to the bottom, it instantly starts to climb. This here is a side view of of that system. Number 29 is a sleeve. The sleeve itself rolls on the wheels. The magnet itself does not touch the wheels. This here is a 560-ton dead weight block in yellow. The greater the dead weight, the more magnets needed to pick it up. You have 1 through 10 through 100. And you have 100 magnets each. Each magnet is 10 tons pull force each. They are neodymium permanent magnets. They are dead weight magnets. This is an oblique view of the dead weight system. And right here is number 19. Number 19 is the, hold on, let me remember this thing. Number 19 is the electric generator rack gear. Electric generator rack gear right here, and this here is the electric generator drive shaft to the electric generator over here. Now, to continue. Now, this is what a total system would look like. The number of seconds that it takes, number 1, at the bottom here, to reach the top of the frame is the number of dead weights in the system. As you can see, many dead weights right here in the system. This is an example only. Number 1. Number 1 right here takes 1 second to fall to the bottom from the top. Zip, bam. Number 2, number 1 right here takes 8 seconds to reach the top from the bottom. Takes this 8 seconds to climb all the way back up to the top. Now, simultaneously, number 2 starts to fall. When this here hits the bottom here, It starts to climb and number 2 drops. And it hits its number 32 right here. And it reaches the bottom and it presses 32 and starts to climb. At the same time, number 3 starts to climb and the process reaches number 9 here, which drops of the dead weights, and it continues to repeat. This number 33 is, each one of these dead weights has an initiator, and this is a small initiator battery, since it doesn't take that much energy to run the initiator. I want to thank everyone for listening and watching, and have a very pleasant day. Share this video, please.